better. Okay, so what you can see here is these boxes. It's actually these little units, these boxes of sort of cubes of boxes, and they are animated to move on, to sort of rotate. They sort of smoothly rotate 90 degrees, X, Y, and Z, kind of sequentially. And you can see that the ones that are closest to this sphere are moving fastest and are also orange in the light that's on them. Whereas the ones that are farther away are moving slower and have a green light. And if I, as I move this sphere around, I get this reactivity in a sense, this time-based, this speed-based reactivity, as well as color. And we could even get rid of the color. Maybe that would enhance the effect here. But there we go. You kind of get a pretty good sense of it here. And I've got this whole field of them, so I can kind of move this sphere through. And this could be anything. This sphere could be just me in the space, and as I approach, you get this effect. Just sort of have this sphere behind me. Let me just grab it a little closer. So this would be what it would look like if it was just me. As I move a little closer to these. I made my fly pretty fast here. The effect, the locomotion of my VR rig is really fast. I cranked up to 24. I thought this was a bigger field before I went in, and it was much smaller, so I don't need to move nearly as quickly. So this is much more gentle movement. So if I were to just be looking at this as if it was me approaching, you can kind of see what it's like to have this sort of time warping effect around you. Which is kind of an interesting concept, that if as you travel through the world, the things near you would speed up. Sort of a weird kind of take on time relativity and kind of space-time. And it's not exactly, like traveling in time, but it's this really interesting kind of thing, and I feel like there's probably some really interesting animations that would really emphasize this effect and really give you kind of an interesting outcome from this. So what we're going to be doing is building this today and understanding Simmetry's tool, the feature of the unit plus timeline. Each of these sets of 8 cubes, basically this box right here, this set of 8 boxes is a unit. And this is a unit, and that's a unit. So each one of these sets is a single unit, and it has its own timeline. And that timeline has a timescale property on it. And when this sphere gets moved, it basically goes out to the world, and it says, okay, hello units. Everything of you that is a unit, I would like to get a hold of your timeline and change it based on how far I am from you. Kind of the inverse of how far I am from you. So if I'm really close, I want you time scale. I want the time scale of your timeline to be really big, and if I'm really far away, I want that to be small. So the inverse. And then the other thing it does, and I just sort of did this for added effect, is that there's a light in each unit, and I go and I get the light of each unit, and I kind of change its hue, also based on the distance, and the brightness, I think, as well. I did the brightness. Anyway, so we'll learn the basics of this. I probably won't do a unit with 8 8 objects in it. We'll do just like a single object, and then we'll build our matrix and figure out the code. Let's take a look at the code before we start from scratch, and then we'll build it ourselves. So this is our field in night. I actually have a lens model on the camera, the default camera, not on the HMD, but this lens model is creating, it's got a focal distance and range. I was doing that for the sort of advertising GIF, to have the foreground and background blurry, but have a mid-range that wasn't. I'm going to turn that off. I'm going to get rid of this lens model. And so the code that's being run on this is all happening from one place, and you can see this the little pink indicator right here next to movable ball. That's the indicator of code that's being run on this movable ball. And so if I go to edit code, I can see the code that is getting run, and that the entire effect that you're seeing is happening here. The entire effect that we just witnessed is all happening kind of in, less than 20 lines of code. And what it's doing is it has two functions. There's two functions that run attached to this movable ball. The first one is on initialization, this on init code. And in the initialization, the movable ball gets itself the space, and then goes and searches the entire space. And when it returns all these child nodes, it packages it into this. It's variable for a table that can contain all of the nodes that it's going to get back. So it's going to get back a bunch of nodes that include a bunch of different units and the movable ball itself. That what it does is, as it's initialized and it goes out on that very first pre-frame of playtime or present time, it goes and it gathers all those units and packages them up here so that we can access them later in the second function. So the first function is the packaging, and it packages it up into what this is called a member variable. It's a member of the movable ball, which is mesh entity in this script. And so the dot nodes is a table that's going to contain all of our nodes. And so when we say self.nodes anywhere else in the table, we're talking about this mesh entity dot nodes. So this value is being referenced anywhere else by self.nodes. So when the ball initializes, it packages it up a table of these nodes, and then it says when I move, if my if the movable ball moves around, and I am in I'm in playtime right now, and the movable ball is here, and so if the movable ball does move around, the movable ball moves around, it runs this onMove function. That's the onMove event of the movable ball. Under events, it has the onInitialization event, and it has this onMove event. So anytime the transform is updated, this function runs, which means, and the reason that we're doing that is because, if the ball sits still, nothing is changing in here. The timeline, the speed of these things stay the same, the color of these lights stay the same. But as soon as it moves, we now have the event that means it's time to make these updates. So we package this whole script in the onMove event. So when it moves, it goes and it makes a little variable here that it can reference, which is inside this scope of this function. It's going to call a variable named nodes, which is equal to this thing, self.nodes. So that's going to be a table of all the things in our space that we got on the initialization. And then we're going to go and look at each one of these from the first one to the number, the amount in the table of nodes, we're going to do the following. One, we're going to test exclude myself. So we don't want to run this function on the movable ball, that we know. And we almost don't need to write this, and I'll tell you why, because of the next one. So we're going to exclude myself, and we want to make sure that the type of the node, the thing that, for each one of these that we're looking at, for each one, meaning at nodes at the index of I, we want to make sure that it's a unit. So if it's equal to a unit, then we're going to do the rest of it. So it needs to be a unit. We can't run this function. We can't do this stuff and change the time scale of the movable ball. It doesn't have a time scale. These unit timelines are the ones that have time scales. So and that'll make a little bit of sense. That'll make much more sense when we build it up a little later. But basically what we do is we come in here and we get the length, the distance from our self to each node, so each one of these units, and then we get the length of that, and we're going to take the absolute value of that. So if we're near or far, we're getting the overall length of that vector in space. And then we go, and this is when we get the timeline, and we go and get that timescale property. And this is when we change the timescale, and we kind of tinker with this until we get it towards an effect that we like. So that's the timescale change. And we're now using this distance variable that we calculated here. So what's the distance between ourselves? And then we use distance here to change our timescale. And then we're going to go and find the spotlight's dot color property, and we're going to change its hue by the distance. And we don't change brightness, but we're going to go the hue, saturation, brightness, and we're going to change the hue is going to be distance times 25. So if we're 10 units away, this will be its maximum because this value ranges from 0 to 255. So if we're 10 meters away, we'll be at 10. We'll be at 255, and if we're 0 or if we're 1, we'll be at 25, and if we're inside of that, we'll be. So we may play around with this to get kind of a color ramping effect that we like. But that's the basic idea. Get all the objects. Make sure we're only working on units. Calculate the distance between ourself. And this is because this code is running on the movable ball. From our self get world position to each of our nodes world position, and just get the flat out length of that and the absolute value of that length. That's the magnitude of that three-dimensional vector. So that's just the overall distance. Then we just scale the time scale based on the inverse distance, 4 divided by distance, and we change the color. And this is a movable ball, so I should be able to roll it. Even in present time, but present wants to go into VR now. So that's what the effect that you get, and we can change the values. So let's learn about unit and timeline. I'm going to go ahead and create a new one, a new show, and we will build this up from scratch. So the way that this works is we're not just going to build. We're not going to just start building in the space. We actually need to build inside of a new unit. And the way that we do that is down here on the plus button on our hierarchy, we can create a new unit or a new unit plus timeline. And we're going to create the new unit plus timeline. This is where the magic happens right here. Okay, so in our new unit, this is where we're going to build the thing that's going to get animated. And so let's just go ahead and do a simple box. And you'll see that when we draw, there's this gray this gray outline, which means that we are, and you'll also see this little arrow like so, which means that we're inside the unit's context. We're in the unit package. We're not in the terrain space, so we're drilled down into the unit territory. And we can create all kinds of things inside of a unit, and the unit boundary keeps getting bigger. And they all stay inside the unit. If I clone off things, if I press Control C and Control V and decide to place things, all over the space, it acts like I'm building just into a normal space. But that's inside the unit, and you'll see them all populate down here. The other thing that we have is that the unit is kind of a subspace of our terrain space. Remember, our top level is the universe. We can create different types of spaces, new terrain spaces, almost like separate planets. We can go create another open space or a sky space or whatever. But each space will have these subspaces that are then considered units, and each unit has a separate time library. So there's a terrain space that has its library and its materials and its timeline. And the unit plus timeline has, not only does it have its own library, but in its library it has its own timeline. And this is the thing that we're going to be getting a hold of in our script that we're learning today. So we're going to be working on this timeline. And what I'm going to do is actually change its name to unit timeline so that it visually never conflicts with the other timeline. So we'll have the terrain space timeline, and we're going to have this unit timeline. And when we make lots of copies of this unit plus timeline, there's going to be many different unit timelines, but we're not going to be tinkering too much with them. We're just going to be animating one time. On one unit timeline, we're going to be making some animation properties on one unit timeline, and then we're cloning those away. And then all we're doing is changing the time scale of those. So they'll be basically identical, except we'll be changing the timeline. So here we are in our unit. To get into a unit, if you're in and out of a unit, you need to drill into the unit by double left clicking. I'm sorry, let me return. There. So you can now see my keyboard callouts here. So I need to double left click to be in the unit territory. And you'll see that when I've done that, this little guy appears, this little up arrow, the gray box appears. I'm now inside. All I see is the unit. I don't see the terrain space in the camera. And then I'm also selected on this unit. Additionally, I can double click on this unit, and I will also get that gray box, that arrow, and I'm in that unit. So there's a number of ways to get in and out of the unit. If you want to exit the unit, double click on the terrain space or anything that's not an object in your unit, and you'll now be in the terrain space. You'll see the default camera, and then there'll be you and any other units that are inside that terrain space. And again, you won't be selected on the unit. So to drill into the unit, again, double left click, and you're into the unit. Additionally, once you go drill into the unit timeline, the timeline for your unit should be selected. If it's not, you need to select into the unit library and double click the unit timeline up here so that your unit timeline is the tab that is selected. You can also select the tab down here. You want to make sure that your unit timeline, not your terrain space timeline, is the one that you animate your unit property. The properties that you want to animate in your unit need to happen on your unit timeline. Okay, so we're ready to animate some properties. I'm going to make this thing move, and since I'm going to animate its movement values, I need to make the rigid body either non-existent by removing it. I need to make the rigid body either not active or not movable. So I'm going to make it, I'm going to remove it altogether. And so that means that when I tell the box where to go by the timeline, it's not also going to fight the physics engine. So this thing's going to work kind of just like a visual shell, kind of ghost object that won't collide, won't react to gravity, and it's just going to take its orders of its position from the timeline. So I'm going to transform, add a, I'm going to add a new key track on the transform. So we've got this box selected. Again, we're in the unit. We have the box selected. Come up to its properties. Add a new key track on its transform. Clicking this little triangle. Add new key track to its transform, and you'll now have a transform key track. I'm gonna change its title by clicking here and say box transform key track, just to remind myself its name. And I'm gonna make like a 4-second loop, which means that I want a time keyframe here on 1 second, 2 second, and 3 second, and then we're gonna loop it back to its home position on 4. So I created those by just double left clicking into the space. I'm gonna right click in between the keyframes to create to select a interpolation. I'm going to use smooth in this case. And if I right click on my keyframes, I can start setting some values. And I think what I want to do is on my second one, I'm going to right click. I'm going to have these things go up in the air. And then I want them to rotate like 90 degrees. And you could do anything you want here, honestly. And I encourage you to explore, because the possibilities are limitless. You could change the color, you could change the scale, you could change its shape, you could add a new keyframe on its dimensions, you could add more, if you were using like a sphere, you could change the amount of subdivisions. If you're using multiple objects, you could add, create a whole crazy dance. In the demo that I gave you in the beginning, I had 4 objects, each spinning on their own local rotations, which meant that I had 8 cubes, which meant that I had 8 tracks down here. Anyway, I'm just gonna do the one simple. It's gonna go down. It's gonna do some weird kind of rotate thing, and maybe at its top, I'm going to change its color right as it gets to its top. So I'm going to go to select the box, come up to its top level, come down to color, and I'm going to select this and create a new key track. I'm going to do a new key like this. I'm going to do a new key like this. And then what I want is from here to here, I want to smoothly go in and out of a brighter value. Kind of incorrect. I want the brightness to happen here. So you can multi-select and move your keyframes around. Not bad. And then I can also clone this one away. So if I right click it, if I right click the keyframe, I can see what it is. I can visit a view of it. I can hold down Alt and drag away a value. So now I've got kind of the dimmer white, a brighter white, and a dimmer white, which will get me the effect of. I'm gonna do like just exponential ease out here. Not bad. Really doesn't matter. We'll kind of see what happens when we get many of these in place. Okay, so we have a unit. We have a box. That box has properties. Those properties are getting animated on the timeline. That timeline lives in the unit. You now have kind of all the machinery to be ready to clone all these objects out. Clone a bunch of units. So we're going to not be cloning the box. We're going to go back to the terrain space and clone out some units and see what that looks like. So I double clicked outside of the unit, and now I can clone away many of these, and I'm in stop time. If you clone them away in playtime, when you first clone them away, you'll see that they each unit's timeline will start at it'll start at time 0, so you'll get kind of a staggered start time, which you could do dynamically through script if you wanted, but I forgot one thing. These aren't looping. So I was wrong. You do not have exactly the machinery you need. So you can see that it's kind of cool once they start acting like, I don't know, it kind of looks kind of like a military parade kind of a thing, but or like a factory part. We need to drill down into this unit. This one is a unit copy. It's not the original. I can change its name. I deleted away a bunch. So we're going to drill down into the unit, double click it, and then we just need to make these tracks. We need to make these loop. And the way that you do that is you select the track itself and come down to this second item. So I went from box, transform, key track down to the second one to transform. And we're going to go to loop padding time. And since I'm basically at 3 seconds, the padding between when we loop, I'm going to set to 1 second, but you'll see what happens here. Oops. Let me set 1 there. Oh, I've been touching the keypad. Excuse me. So this should be 1 in loop padding time, and you'll notice that it brings this the next start frame out to 4 seconds. And I'm just going to do one more interpolation between now and this right here, this little keyframe that it pops in that's coded in red. It represents the 0 point of the beginning, so it's like come back to the beginning, and then the padding time is basically everything between here and here. So that loop padding time is 1 second from here to here. And I'm just going to put an interpolation in here as well, and I'll use smooth, and that's pretty great. Okay, so I'm going to do the same thing for color key track. Loop padding time, I'm going to make, I keep selecting this wrong. Control A, hit 1. Yeah, my recommendation here is when you come to it, hit Control A and then hit 1 on the loop padding time. So now I have loop padding, and you can see these little ghost key tracks proliferated out to the right side. So I'm going to make this color This one I'll just say smooth too. So now you see that my timeline, if I press play and press the space bar there, it'll repeat indefinitely. So now, honestly, you have everything you need to clone out a huge field of these. I'm just lasso selecting, holding down Alt and Shift. So that I can kind of constrain the movement to an axis. Very cool. And you'll see that we have, if I like drill into one of these units, that unit is going to have a timeline. And if I change that time scale, you'll see it starts to lag behind because I made the time scale slower. So it's this effect right here that we're going for, which is grabbing the unit's timeline independent of the other units and changing its time scale dynamically. I'll reset that. So let's set up the script that does this. It's going to get all the units and store them in a table. So we're going to run that, and I'm going to show you this on so you can do it on a screen using one of the actors. So we're going to use the movable ball under actors. And we're going to draw a movable ball. And when we press play, our controls W, A, S, and D move the ball around. You can also select the movable ball and come to this settings, these settings here, and crank up its power if you want it to move a little bit more assertively, greater acceleration, and then when it's max speed, it can move around a little faster. So now we have an object that is going to be can move its position. Its position will be dynamic, and now we can basically relate the relative position between that object and each unit to a timescale property. And so let us set that up. And so that means that we're going to put the script on this ball. When it moves, it's going to be the thing that affects goes and affects all of these objects. So on this sphere, we're going to make an initialization event, and we're going to make an onMove event. First, the thing we want is a variable at the very top that we call mesh entity dot nodes, and this is going to be, we're going to run this once. This is going to be where we store. This is where we're going to store all of the nodes at the very beginning, at the very initialization point. So this is going to be the table that we want to store to. And to get all of the nodes, we first need to come from ourself, from the movable ball, we need to get the terrain space. So we're going to say self get space, and that gets this whole space. And then we are going to get child nodes, and that's going to get us all of the nodes that are the children of the terrain space. That's going to get us the default camera. It's going to get us the movable ball. It's going to get us all of these units. And so we're going to say self get space get child nodes. And child nodes is a function that needs, you need to tell it what table you want to fill. It says give me a table and I'll give you, you send me a table and I'll fill it with a whole bunch of nodes of the child of this thing here. So we're going to send it this table. We're going to send it this table mesh entity.nodes, but when we're in this context, the way to access this is called self.nodes. So self.nodes is this thing. We're going to pass this thing in, and then we're going to get this. We're going to go to the mesh entities, the self, get space, get child nodes, and we're going to basically pass in this array right here, and we're going to get all of these things inside of it. So now we can just access this in our next. Whenever we move, we now have a library in a sense. We now have a list of all the nodes that we need to kind of loop over to figure out if they have a timeline, if they are a unit, and if they will go get their timeline. So the way that we do this is we're going to, as we move, at the frame at which we've moved, we need to run a loop over all of these objects and test if they're a unit, and then change their timeline if they are. So this is a for loop. So we're going to say for and we're going to say I equals 1. That's the initialization of our iterator. And then we need to loop it until we've gone to the very end of until we've gone through the end of our table. So we need number of nodes, which is the amount of nodes, the count of nodes that are in this table. So from I equals 1 all the way to the number of nodes, we're going to do something. And now we're going to write a conditional statement just to make sure that it's a unit that we're going to be working on. And so we're going to say if the item at the ith at the I position of the table in nodes, if nodes at table I, hang on a second. Make sure I'm doing this correctly. So this tests the type of the unit. So this is a little function where you pass in, you put an object into it, and it spits out a string. And that string you can compare to the different types of objects. So a unit is a type of object. And so you say type, open close parenthesis, and then you pass in the object that you're testing. So the first object you test is nodes of 1. Then the second one comes in as this clicks over to 2. It'll be nodes at 2, and you test the type. And if the type is equal, 2 equal signs, is equal to unit, then we can do our test on it. So when the type is not, when it's the movable ball and it's a mesh entity, we will skip the code that's in here. When it's the default camera, when it's anything else that you draw in the space, it won't satisfy this condition. The type won't be a unit. So we're now ready to do something that is specific to units plus timelines, and we're going to say at the nodes of I, this is the first object we come to, then the second time we run this loop in this for loop, it'll be the second one, and so on. So nodes of I, we need to get the library up here of that unit. Remember when I double clicked it and we were looking at thing that was up there. Well, that's where the timeline lives. So that's called, what we do is we get instance library. And so notes of I get instance library, open close parentheses, then colon. So that gets us the library. Then we need, I'll demonstrate. So like if we double click on a unit, getting this unit's instance library brings us to this library, and in it we have a thing called a unit timeline that we need to get a hold of. Get instance library, and then we say find object by name, open close parentheses, and inside these parentheses we need to do pass in a string, so it's going to be quotation mark, and inside of this we need to say capital U-N-I-T unit timeline. It needs to exactly read what this is, the name, right? We're finding the object by name in the library, so it needs to be spelled exactly with spaces and stuff. No space at the end, capital U, unit, space, capital T, timeline. So that should return this timeline. So now we're ready to do something to the time scale. Dot time scale. And so if you click on this, if you were to click on this unit, the unit timeline inside the unit, you'll see this value called timescale. That's what we're going to affect. And so just like any other property, the convention is to bring it in, camel case it, which means lowercase the first word, no space, uppercase any words after that. So it's going to be lowercase t, uppercase s for timescale. And then we're going to set this value to something. And let's take a look at, so we don't know what we're going to set it to yet. We need to run a calculation before we set this to something. Let's say we're gonna set this equal to dist, but we don't know what dist is yet. So we're actually going to come up one line above this, and we're going to do a little calculation. Because we need to make a calculation about how far our unit object is. This unit, which is represented here at this context in the code, is by nodes of I. We want to know how far it is from this sphere, which in this is referenced by self, because all of this code, remember, lives on the onMove event on this sphere. So we're going to basically say dist is equal to, and it's going to be equal to our self, this object, its position. So self colon get world position, open close parentheses, minus nodes, the table of nodes at the placeholder of I, at the index of I, colon get world position, open close parenthesis. And so that's going to return a vector 3, but distance we don't want as a vector 3 because time scale is a single dimension value. We don't want the vector, the three-dimensional vector. We want just the overall distance point to point. So we need to take this calculation and put it in parentheses, and then we're going to hit colon and run the function length, which can be run on a vector 3 and just gives us the magnitude of that vector, the overall length. Now that's one-dimensional. And that value will range into the negatives, and we don't want like a negative time scale. Time scale only goes from 0 to 1, so we just need to take the absolute value of this. Again, we're going to put parentheses around the whole kit and caboodle here, and we're going to say math.abs, and that'll give us the absolute value of the magnitude of the vector, the three-dimensional vector in the offset between these two. And it'll always then range in the positives. Great, which means that when these things are in the same position, distance will be 0, and when they're far apart, distance will be a lot. So if I want these things to come to a 0 time scale, which means to like to a halt when they have no motion, I need to take the time scale and set it to set it to dist, which means that if they're near each other, dist will be 0, 0 will be timescale, timescale will be at 0 is standing completely still. Okay, let's see what that looks like. And we've got an error. Let's begin to debug. Attempt to get length of global nodes. Perfect. So one of the things that I forgot to do here is there's nothing called nodes yet. I need to, there is no value. I haven't, in this function inside of mess entity on move, I haven't declared anything called nodes. But as soon as I got to this line, I said, yeah, do run this loop from number 1 to the amount of, like, the count of the nodes table. And it's like, the computer says, what do you mean nodes? I don't know any nodes. What I'm saying here, what I mean to say is self.nodes. I want this thing, which we filled in our first immediate moment on initialization. So I need to say self.nodes here for number of self.nodes. But at this point, what I'm going to do is just make another variable that I call nodes is equal to self.nodes. So now we have a instantiation of this variable called nodes, which is the same as self.nodes. So let's see if this works. It's kind of hilarious. So they come to a standstill here when I come through them. So what if we want to do the reverse, such that they gallop, they go faster when I come near? We can select our ball and just right-click to hit Edit Code. And to make them move faster when I am closer, we need basically the inverse of the distance. What that means is, as we get closer in distance, the number gets smaller. We need some overall value getting divided by a smaller number. So if distance comes to 0, 1 divided by 0 will basically go up to infinity, and these things will go super fast when we get really close. But if it's like 1 meter away, this thing will be 1. When it's 2 meters away, this thing will be half, so it'll be slower when it's farther away. So let's see if we right click. It's not happening fast enough. I'm going to right click and hit Edit Code. So I'm going to say that I want it to be like 4 divided by the distance, which means it should be a little larger when I'm closer. And so now I've got this reaction taking place in a pretty cool way. This one's interesting because of the movement. It ends up in a pretty kind of chaotic level. And you can do all kinds of calculations to, change these. To change the effect. You may want to divide this. You may want to square this. That's kind of a nice, it's like inverse square. It's kind of cool because it's almost as if there's an interesting other way to think about this, which is that we made these things fairly, the repetition time on these on our units, the repetition time was like 4 seconds, but you could have a drastically longer timeline that maybe even doesn't repeat, like it just expends itself. But with this effect, double click out of that unit, with this effect where we are using some value in this inverse, the square of the distance, it could be the cube of the distance, where there's almost no motion until I begin to get near it. See, at this point in the process, there's this nice kind of curvature taking place, where time has sort of swelled these into progress, and it's obviously very radial. It's very circular. It's clear that the geometry is sort of expressing itself here. Then once they start to come down, and they do sort of a self, the part of the animation that's kind of chaotic or non-linear, the overall order starts to dissipate, but you can still see this white arc expanding through them, through the field, and now it's kind of repeating as each of these sort of moves through its timeline. What's wild is that we're processing time, and those time is related to these like discrete actions. Anyway, I think there's a ton of stuff that's be fun to play with, and I think your main levers to work with are the actual motion quality of these animations, the amount of items that are in it, and the motion that takes place. The overall duration of your animation could be really interesting, and the then the underlying mathematics in the code, where you're changing some value, the way that you change the time scale based on the location. You should be able to add this to a lot of the stuff that we've learned up to this point, as a possible addition, possible way to combine this with other things. Obviously, you can combine this with VR. The way that I did that was by my fastest way of doing that was making this object grabbable, and then throwing a VR rig in the space and then grabbing it and moving it around. But this same principle of the thing that moves, you could put this code. I could put this same code on my VR like hand, or on the VR rig itself. Everything here, the only thing that would really change is this name needs to be the name of the VR rig, which I believe would be node. So if you wanted to do that, let's put it just on the VR rig itself. For example, I'll show you how to kind of copy over code. So let's just hit Control A and Control C, and actually we're gonna hit Control X in this case. I'm just gonna totally lift it off of this sphere, and then what I'm gonna do is put a VR rig in the space. We'll go to VR rig preset, and then I'll rotate it so that it's first rotation is pointing at our field. And then let's take a look. So VRRig is going to have code already on it. Some of the stuff that's like already helping make it much more easy to use. And you'll notice that it has this thing, does viewport render to space. It's got a function called onInit. Oh, that's one of them that we were just using. On active update, I'm not familiar with that. On present, I'm not familiar with that. So we're going to ignore active update, and on init, we did something on init last time, and let me just paste my code into here. Eek. So the thing that we did on init was we said self get space get child nodes, and we put them in a variable. So how do we do this? So we have this thing called mesh entity dot nodes is a table. So let's figure out how we get that onto this VRRig. Well, you'll notice that the VRRig has a function. When it says function, it calls function on a thing called node. That's its default name inside the code. And if we look at the VRRig and we place an event on it, an onMove event, and we scroll down where it'll place the onMove. Let's see where it placed onMove. Oh, it already reads this onMove, doesn't it? So the first thing we need to do is make the mesh entity nodes variable no longer say mesh entity. It needs to say capital N. It needs to say nodes. And then we're going to cut this and paste it at the very, very top. Sorry, it needs to be capital N-O-D-E. Node.nodes is this. We're reading this off of node colon onInit, which was here. Node will be the name that it needs to declare this on up above. So now self.node nodes will reference this up here. And we're going to fill up a thing called self.nodes, which will fill up this table up here. Our functions that we write need to be node, function capital node. We have an onInit that's up here, so we're going to paste in from our original init. We need to paste that into the init that's already in here, and then we'll get rid of our old init function container. And so now during this init, while these other things take place, or after these other things take place, we're going to go do the thing that we did on our sphere, which is self get space get child nodes, self.nodes. That's going to fill up the table with all these other objects, and it's going to return this table of all these child nodes. So this function, the onMove function that we had, everything else should be pretty good to go, except it just needs to be renamed. Instead of mesh entity, we're now on, what does it say next to onInit? Capital N-O-D-E. So we need to call this capital N-O-D-E onMove. So that'll be our function there. Inside of our onMove function, there's nodes is a variable that we're calling, and we're filling it up with self.nodes, which references this. Okay. Then we run our loop, and we go and we get our own world position. Great. If we fly around, things should calculate distance correctly, and everything else should be fine. So the main things you need to do is get everything into its proper home, which means that that declaration that was at our top of our prior object needs to be at the top of this new script. It was at the top of the last script. It needs to be at the very top of this script. The item that was in our init, our initialization function on our sphere, now needs to be here inside of this init. There can't be two init functions. There has to be only one. And since we noticed that in this context we were calling on init onto the node, we need to make the onMove function be called node onMove. Because the function needs the proper object name in here. And we've got node on active update. So that should do it. And now I'm moving the VR around, with the mouse, but should we fly at things? As soon as I moved once, you could see they all sort of went into that appropriate timeline. And as I get closer, certain ones are going to speed up. You can kind of see there's like an arc of the effect that I had as I came in. So there you go. So that we've moved it to the VR rig itself, and then it ran. Yeah. So bringing code across from one place to another is just a matter of organizing where the the declaration of the variable goes, the member entity, the member object, member variable here, making sure it goes right at the top, making sure that the name change from mesh entity to node took place, putting the onInit into the onInit, and putting the onMove, getting the onMove named correctly, and then the reference of self.nodes still works. Everything else should still work just fine. We go out, we get our list of items. We go and get, if they're units, we go then calculate a distance and change their unit timescale to some change. And that should just about do it. Yeah, I guess the only other thing I would say is that if you want to change all of these objects, the only way to do this, since these clones need to be full copies, the only way to if you want to change the timeline, if I came into this unit and I was like, oh, I want to make it take place longer, that first step should take place. Sorry. Let me get this sorted here. If I wanted this timeline to happen over a different time scale, or not, sorry, if I wanted the motions and the keyframes to be spaced out differently, and I wanted that to be affecting all of these objects, you can see that I did this on the 1, but this 1 is now a straggler. It's right. All these other ones have the original properties from whence we cloned them prior. So what I need to do if I want to get like this object, if I want this new test, unfortunately, there's no real great way to do this except you just need to come out, knock these away, and reposition them. The only other way that you would be able to really do that would be through a much more kind of complex, scripting scenario. But you can build out your matrix again pretty quickly. Kind of awesome in this funny way, like your presence near these objects kind of how do I say, perturbs them, kind of sets them loose into like chaos. Which is kind of cool. Yeah, and when you get far away, this object looks almost completely static. But there's very little motion to it, and then you start to get closer, and it takes on a life. This is an interesting side effect that I hadn't been thinking of. Let me get you a full frame. Under Preferences, if you go to your HMD and add a screen display and place it, what you'll end up with is the monoscopic view. I'm always want to remind people. It's actually kind of cool to catch it at a distance. It's kind of like a kinetic sculpture in that way. It's like it's almost like a Schrodinger's cat meets artwork, where if I wanted to like view the artwork up close, I start to change it. Not exactly, but I think you get the idea. Yeah, this is pretty cool. Yeah, I really wonder what the... Makes me want to play with so many different animation types. Like when they actually move through space and intersect with each other, that's kind of interesting. But also them just kind of spinning in place, or even just sort of like pulsing in and out at their locations. Could be kind of cool. All right, well that's good. Called that time fields, and that's a fun effect to play with, and I'm gonna sit here and tinker for another minute or so, and I think I'm gonna play with like a projection on this, and see what I end up with. So signing off. Catch you next time. adding some grips so I can fly these around in VR. Just making them bright so I can see them in the dark. Put the display, the monitor material, so that monitor material has self-illumination map, which is this camera display texture. So open up the default and go to illumination.